I'll also.
All right, guys, so welcome to our first workshop of the year. Today we're going to be covering the very interesting and useful topic of 3D printing. So you'll notice we have a little tiny URL on the bottom left of our slides, and that's just a link to the slides. I would recommend you go there because we're going to have a couple links you might want to click on throughout the course of the presentation.
And please check in here for the workshop. It's just for us to gauge who came. And the link to the slides is at the bottom. It's kind of being covered by like the Google Slides thing, but it'll pop up very soon. Or you can just click on that link to look at the slides we're looking at right now, and then click on that Google Forms. And this was also a response to one of the workshop ideas for the project applications. I don't think we can host how to get a live workshop, but you can come talk to us personally.
I'm not sure I have enough expertise in that area. All right, so for those of you who haven't seen us before at the general meeting or the project's info session, let's do a quick introduction. I'm Travis Graney. I'm a second-year electrical engineering major. So my two main hobbies are basketball and music. And as you can see in the picture, Jackie and I played on an intramural team last winter, which was a whole lot of fun. Yeah, and I also like to play a lot of instruments, no wind instruments though, unfortunately. And now that I'm not living on campus, one of the things I miss is walking up and down the hill every time I had to do anything.
The leg workout. Hi everyone, I'm a fourth year computer engineering major. I was originally EE and then switched to CE the beginning of my third year. Some things I like are anime, basketball, dogs, and when I was on the hill crying the Sprout 4 North stairwell. Very peaceful there, 10 out of 10. I also can give like fades for like haircuts, so like if we ever do come back to campus, like I'm down to give you a fade for free as a bonus for the workshop.
So a cool thing we're going to be doing for this workshop is we're going to be giving out a couple prizes like we promised before, and they will actually be $5 Amazon gift cards. So we're going to do 2 of those throughout the course of this presentation. We're going to have a Kahoot that Jackie made at the end, and there's also a question in the middle of our workshop that we're going to give out a gift card for. And so what we're going to do for that especially is we're going to have you put your answer in the chat, and then once we've selected a winner, you can also put your email there so we can reach out to you with the code.
And if you do have any questions during the workshop at all, just unmute yourself, interrupt us. We welcome it, and hope you guys learned something today.
Indeed. Let's get started. So we're going to be going over a range of topics today. The first half of this is going to be basically a lecture portion where we go over the conceptual stuff. And then the second half is going to be a more hands-on tutorial that Jackie has prepared so you guys can actually get some sense of what it feels like to do this for yourself. So some of the stuff we're going to be going over is, first of all, what exactly can be 3D printed? What are the capabilities of what we have and what we're dealing with? Then more generally, what exactly is the process like? What is 3D printing? Some different types of 3D printing and 3D printers, and along with that, different types of materials that are used and all those different types. And perhaps most importantly for you, we're going to go over an overview of how to actually do it, how to create your own model, and then how to go from that model in your CAD software over to a slicer program, and then from there to the actual 3D printer, so you can make your object. And then as you can see at the end, we're going to have a tutorial for both the Tinkercad part of it and for the slicer. So first of all, what exactly can be 3D printed? And the answer to that, and what makes 3D printing such a useful topic, is that pretty much anything, any solid object at least, can be 3D printed, with the caveat that you have to design it first. Now, if you have had the privilege of actually living on UCLA's campus, if you walk by some of the maker spaces, particularly the one that's outside of Feast, you can look inside their windows and see a whole range of things that people 3D printed, which is kind of cool. And that can give you a pretty good sense of what people usually use this stuff for. But if not, then here's a pretty good representation. It can be models, toys, phone holders, keychains. Chances are you've seen them around if you don't actually have any 3D printed stuff yourself. So theoretically, if you had a whole lot of plastic and a 3D printer, you would never have to buy anything except food from the store again. So now that we know what we can do with it, what exactly is the process like? And so as we've mentioned, it's the process of actually making a 3D physical object using a printer. And this comes from a digital design that you create using something called a CAD software. And if you're unfamiliar with that acronym, it means computer aided design. And the actual process works in that the printer will build the object up using very, very thin layers of plastic until each layer is laid down to make your completed object. And why this is so useful is that it can be done quickly. Now, by quickly, I don't mean in just a few minutes. I mean, often 3D printing can take even a couple hours to make something. But when you compare that to what people used to have to do, which was make a wax model of the object and then use metal to make a mold and then inject that mold with plastic, we're talking a whole lot shorter of a time for 3D printing. So a couple things about 3D printing. We'll go through 4 steps that are inherent to the process. So as we mentioned before, we've got our CAD software design in the first place, and that's your first step to sort of get what you want to made. And then from there, you'll export a .stl file from whatever software you're using. And we'll get more into what a .stl file is later. And you can't actually put that directly into your 3D printer. Instead, you have to take it to what's called a slicer software. Now, slicer softwares are going to be particular to the family or a particular kind of 3D printer you're using. So we'll get into a little more about that later as well. And then from there, you're going to export a second kind of file, in our case, a .gcode file. And that's actually what you're going to put onto the 3D printer. And once you do that, you can specify some settings and print it out, and you'll have your finished product. It does not have to be Pokemon, and if it is, I would recommend making your Pikachu yellow rather than green, but I guess that's up to your personal preference. All right, so let's go over some kinds of 3D printing. So the first one, and the most common kind, is called fused deposition modeling. And this is a pretty inexpensive kind of printer. Most of the desktop printers that you'll see is this kind. And so what it will do is it will just heat a kind of thermoplastic up until its melting point, and then put it out through a nozzle onto a printing bed. You can see on the top right image over here what that process looks like. And this is a really good example of the additive layer manufacturing type of printing, which is just adding layer upon layer of material until you have your finished product. And lastly, those slicer programs I talked about before, those are what are going to cut your CAD model that you've made into layers and tell the 3D printer exactly what layers to lay out where. So this is what we're going to be dealing with today. But before we move on, let's talk real quick about stereolithography and selective laser sintering. So stereolithography is a resin-based kind of 3D printing. And so this actually uses UV light to harden a resin layer by layer until you've made your finished product. You can see what that looks like in the middle. And then on the bottom is the process of selective layer sintering. So I was kind of confused as to the word sintering, so I had to actually look it up. And apparently sintering means to cause to become a coherent mass by heating without melting. So there's our vocabulary word of the day. Take that as you will. And so this is a nylon-based kind of 3D printing, and it actually uses a laser to harden the nylon layer by layer until you have your completed product. So let's talk about some materials that you might use in 3D printing. One of the big ones is ABS, plastic. I'm not going to try to pronounce what that actually is, but if you've ever built with Legos before, you're very familiar with this kind of plastic and all of its properties. So this is an oil-based, very strong plastic, and it's impact resistant, as you'll know if you've ever actually stepped on a Lego, which I'm assuming at least probably 60% of us have. And it's also heat resistant. So this is a really good option if you want to make something that's durable and nice and hard and shiny. So a second option that we have is polylactic acid. So this is a lot less durable than ABS, but it's also easier to print at lower temperatures. And this property makes it something that is used a lot in your home 3D printers or desktop 3D printers. And as a side benefit, it's also renewable and biodegradable. So those are the 2 kinds that you're probably going to see most, like around the labs and maker spaces on campus. We've also got these 4 options down below, which you don't need to get into a lot, but it's just good to have their names in your mind. We've got polyvinyl alcohol, PVA, nylon, which we saw in the selective laser sintering process, and resin, which you also saw on the last slide. And lastly, steels and metals, which I think is actually pretty cool. You're probably not going to see that unless you actually go to a manufacturing place or something like that. But you can they actually do have metal 3D printers these days. Alrighty, so we're going to go through the steps that we're going to need to go through to actually create your own design. So our first step is to get that 3D CAD computer-aided design out of the way. And there are many different softwares for this. What we're going to be using in Jackie's tutorial later is the Autodesk Tinkercad, which is good because you don't actually have to download a software to do it. Instead, it's just available online. And so all you're going to have to do is sign up a little bit later and you can actually use their software. However, later on, if you want to get into a more professional kind of 3D printing process, there's also Fusion 360, FreeCAD, and SolidWorks that you can check out at a later time. So once we've got that finished, and once again, Jackie will go into how to do that later, we export in an STL file. You can see that there's also another option over here, a .obj file, which we'll talk about a little bit in the next slide. But this is our exporting step. So what exactly is that .stl file that we've been talking about? So what it means is a stereolithography or standard tessellation language file. And it's a very common way that, that 3D printed CAD files will be exported from your CAD design program. And so what it does is it will encode the surface of your object into tiny triangles, and they'll be non-overlapping triangles that will map only the surface geometry of your object. And what this means is that if you try to add a texture in your CAD program, it will not actually register in the .stl file, and also colors and other attributes like that will not be represented. So if you're going to wish to represent anything more than that, then you go with the .obj file. And so this will have those attributes like your color and texture, but it will also take up a lot more information. And that means that your 3D printed design will take a lot longer to print. All right, so let's talk a little bit more about those slicer softwares. We mentioned them a little bit before, but exactly what it will do is it will cut horizontal cross sections of your design. And this is really important because, as we mentioned before, the 3D printer will lay down horizontal layers of its plastic or whatever material it's dealing with to actually create your final design. So in this particular slicer software, it's going to do that, but you can also set certain print settings that will be very important to the process. So let's go over a little bit of what those printing settings are. So as we mentioned before, your basic.stl file will only keep track of the surface properties of your design. And what that means is if you've got a hexagonal solid, like you see on the right over here, all it'll do is keep track of the outside. It won't tell exactly what it's going to be within that object. So you can see over here, we've got different, what is called infill percentages, which is basically the amount of plastic and the pattern of plastic that is used to fill up your particular solid. And we would recommend nothing less than 10%, or else you're going to have a really, really flimsy object. 35% is probably enough, but if you're going to want something that's really strong, then you might want to go a little bit higher. But do always remember that as you go higher, it's going to take a lot longer to print, and it's also going to take a lot more material. So these are things to weigh when you're considering what settings to use. So a couple of other things that you have to consider are, first of all, your outer shell thickness, which, as you can imagine, would be like on the 6 sides of these hexagonal solids, how thick that is. And this is probably okay if you go pretty thin. I would usually go with 2 layers, but 1 layer should be fine since you've got all those honeycombs beneath it that are supporting it. One more thing is the top and bottom layers. Now these I would go a little bit thicker than the sides. I would probably even stray sort of more towards the 4 layers. And that's because I've had a bad experience in the past with printing too thin. It was actually during our IdeaHacks project last year. If you're not familiar with that, it's a very large hardware hackathon that takes place at UCLA in winter quarter. And we were printing a box for the design that we were making. And so we'd already spent a couple hours making a really nice box. And we tried to make a lid. And so after about an hour and a half of printing, our lid started to curl up on the edges because we'd made it too thin. And so that ruined our work. And a teammate and I ended up having to stay up for about 40 hours straight to actually get our project to completion at that point. So be very careful not to make things too thin. Another thing to consider is our overhang. So I'm sure you can imagine that if you try to print horizontally out from a column, that if the 3D printer tries to print plastic into thin air, it'll probably fall down, bend, or break. So that's not going to work correctly. And you can see some examples of that on the right. It looks like spaghetti hanging down from your design. So moral of that story is that if you're going to have an overhang that's going to be greater than 45 degrees, then you're going to want to use some sort of support material below that. And that'll probably be in the form of some sort of column beneath it that's pretty close to the original column that you're going off of. Or you have another option, which is using an optimal orientation on your particular printing bed. And so here is going to be our first question for a prize. So get yourselves ready. So which orientation is going to be best to 3D print the table below and why? So respond in the chat with a letter and a reason, and the first person to have satisfied that will get your email, and then we'll send you out a prize later on. So Jackie, hopefully you can keep track of that because I can't see the chat very well.
I think it is by answering Corwin Fung, but I need to check if they're in the Facebook group. Can you just
All right, Corwin, if you're not in the Facebook group yet, I would recommend joining very, very quickly.
Before I can check.
Oh, Harry posted. Harry posted join to the beginning of the Zoom meeting.
Oh, okay. Can you send your email to me, like through the chat?
Yes.
And then I can give you the.
All right, so yes, the answer is B, which most of you got. And the reason, of course, is that you're going to want to have that solid layer of plastic down first before you start building the little outcroppings. So if we imagine trying to print in orientation A, your 3D printer will have these little spindly legs going up into the air. There's a good possibility they fall over already, but even if they don't, there's no way that a single strand of plastic is going to make its way all the way from one leg to the other. All your problems are solved if you just lay out that bed first and have the legs attached to it. So orientation is a big thing to consider. Alrighty, so one thing to note is that you can use CAD programs for pretty much any 3D printer, but the slicer that you're going to use to import that file from the CAD program into will depend on the type of printer that you use. For instance, today we're going to be using the Ideamaker software, and that's used for the Raise 3D Pro printers that are used in the makerspace at UCLA. Of course, if you're not at UCLA, that doesn't do you much good at the moment. But do note that there's also another kind, a Prusa slicer software that's used for some of the other ones. So just make sure before you actually put your file into a 3D printer that you've used the correct slicer program so that the printer knows what to do with it. All right, then we come to the easy and fun step of putting your .g-code file into the printer. And you can do this with a flash drive, which I think is the most common way. I've also seen some people do it with just a USB cable straight from the computer. I don't know if that's a function that works with all 3D printers, but that is possible. And so from there, all you have to do is finalize things, and you will usually have a progress bar of some sort on the 3D printer control panel that will tell you how close you're getting to your finished design if you can't confirm that well enough visually. And then you can just take out your finished model and it's complete. So does anyone have any questions about that before we get on to the tutorial part of today? All right, then I think I will stop my share real quick so Jackie can get into the second half of today's workshop.
Okay, let me just share my screen really quick. Can everyone see the slides?
Looks good.
Okay, I will present. All right, so everyone go to that link right now, tinkercad.com/join. And then once you're on that website, create a personal account because although we're students, we don't have a class. And then you can just, I think you can sign in with like your Google email. And then once you have that done, just type like Y in the chat or like yes. All right, we got 2 Ys, 3.
All right, now they're coming in.
All right. Okay. Next step, do you have this, I guess, dashboard? When you open or you log in, click on Create New Design. And then this is basically the Tinkercad interface. So in this box right here, you'll see your work plane. This is where you're going to place your 3D object, basically build your 3D model. And then number 2, this is going to be all the basic building blocks that you will use to create your 3D design. So as you can see, we have like a cube or a box, a cylinder, and then I'll go into more detail about what these two shapes kind of do. They're called holes, which we'll kind of discuss later. And then up here, the tools are to align two objects together. You can group them and merge them together. You can ungroup them objects, and you can also flip them as well. And then up here on the left side, you have your typical copy, paste, delete objects. And then finally, number 5, this is where you want to kind of orient your object or for viewing, so you can like rotate your work plane about like the XYZ axis so you have a better view of your object. And then here are a few Tinkercad shortcuts. We'll be going over that in a demo I'll be doing in like 10 seconds, but this is just for your reference if you want to look back at it. So you can like move the frame left and right, rotate it, place objects, group objects, rotate, etc. And then this is what our final 3D design will basically look like. I'm going to exit out of this. Okay, sorry. Yeah, so this is what the final 3D design will look like in the end. And this is the link that I should already have open. And then what you need to do when you start, let me just get this real quick. Oh gosh. Okay. I'm gonna just copy this link for now. Okay, so I'm going to use this real quick. Does everyone have like a blank workspace right now? Okay. Thank you for the responses. All right, so I'm just gonna have the final model right here just for ease of viewing. First thing we want to do is click on import. This is to import that UCLA logo looking thing that we're gonna put on our keychain. So we have the URL, so you don't have to download anything. It was in the slide that I just copied from before. I'm going to paste it and then click on import. And then I'm going to scale it to 20 and then import. And then you should see a pop-up right here. And then if you can see that, or if you're done with that step, you can just press or click yes again. So you go to up here, top right corner to import, and then click on import from URL and then paste the URL that's in the slides. It says not valid URL. Are you copying and pasting it in here, Justin?
Is anybody else having that problem, or are you all?
I had that problem and then I just clicked enter again and it worked.
Oh, great.
Yeah, maybe try to do it again.
All right, looks like Roy had that same problem as well. So yeah, if it's not working the first time, then just try again. All right, so once you have that finished, then start putting some Ys in the chat again.
I think I have. Okay, I can send a link. Can you actually go on that link that I sent and then just download it from there? Like save as and then somewhere else. Okay. Okay. I'm just gonna move on. All right, so now for the shapes that we need in this tag, you can see that we probably need like a rectangle over here, and we also need a triangle and a torus. So first we're going to start with our base, which is kind of like a rectangular prism. So we're going to drag this box into our work plane and then drag this away. And so let's just have, if you click one of the boxes or like vertices of this like cube, it will show like the dimensions that you can change and type. So let's have like a 30 by like 70 tag. And so now we can change the height of this as well. Click on the box, click on the top vertice or top face, and then we just want a height of 5. And then if everyone is done, feel free to write Y in the chat again.
And if anybody's having troubles, also feel free to write that in the chat or speak up.
Where did you get the dimensions from?
Okay, so if you click on the object and then you click on any one of, or hover over any one of these and then click on this little tiny like square surrounding.
Okay, I got it now. Never mind.
Okay.
Thank you.
Perfect. And then now we want to kind of chop off these sides right here with a triangle. So we're going to take this roof right here, drag it in here, and things we can do to the object is rotate it actually. So what I want to do is rotate this so this triangle is sitting flat on our plane. Okay, so there's like these 3 axes of rotation. So here, here, and here. I want to flip it over 90 degrees. Oops. Okay. And then now I want to rotate it 90 degrees this way so that it can, or sorry, not 90. So it can basically cut this edge off. And then I'll show you right now. And then if you want to look at a shape like with a better viewing, because right now it's kind of hard, like this angle, you can either right click and then move your mouse up and down, or you can also click on the shape itself and then click on this little kind of like square-ish icon so that it pans over there. And then so I'm going to rotate this.
Where's the squarish icon?
Oh, this one. So if you click on an object and then you click on the square icon, fit view to selected shape, whatever shape you click on, it'll like pan to over there. And so now we see, let's look at what the length of this is. So it's going to be, so it's 30 and we want 2 triangles to basically fit on this side and this side so that it can look like this. Let's see. So now let's check the dimensions of this triangle. We want to make it 15 because it's half of 30. And then we want to duplicate this. So all you have to do is like Control C, Control V, or if you're on a Mac, you can do Command C, Command V. Or you can also do it like up here, but it's easier to use like your keyboard shortcuts. And then now we want to flip this over so that it looks like this. Okay. Oops, just kidding. Sorry about that. And so now I'm gonna pan over here. All right, so now it's like not aligned at all. So what you need to do is click on this shape right here, the triangle, and then hold Shift and then click on this, the red rectangle right here. And you'll see up here on this bar, it'll say align. So if you click on that, you'll see like some of these like dots appearing. And you want to align it to the top edge right here. If you can see where my mouse is right now, so that it's moved over there. And you also want to align it to this bottom edge right here. And so now you can see the shape, this triangle is aligned with this rectangle. And you're going to do the same thing on this triangle. So you click on this triangle, press Shift, click on this rectangle, and then go to align. You're going to click this bottom edge because you want the triangle and this left edge of the rectangle to align. And then you also want to click the bottom edge. Oh, I think that did it.
So is that making sense to everybody? If you have any questions or you're falling behind, then please speak up.
I think I need to rotate this.
So Sophia's asking if you could explain align real quickly again.
Oh, sorry.
Process.
Oh, okay. Let me just delete this one first, and then I'll show you again. I'll copy and paste this. And then I shall rotate this. And then you can also pan by right-clicking. If you have a mouse, middle-clicking, and then moving left and right like this. I will align once again. All right, so now this is just, I'll just place this right here so it's like easier to look at. And yes, it's 70 by 30 by 5. And so I'm going to click on this triangle, press Shift, hold Shift, and then click on the rectangle so that both of these shapes are selected. You can tell by seeing like the number 2 right here. Then you want to hover over this. It says align, click on it, and then you want to align with, oops, this bottom edge right here. Do you see how it's like kind of like outlined at the edge? You want it over there. And you also want it over here. Did you get that, Sophia? Okay.
Great.
And so now, okay. And now we're going to click on this triangle and this triangle. And then we want to actually make them holes because we want to basically cut out this rectangle. So once you click hole, you should have this kind of like hollow, transparent looking triangle. And then you're going to press Shift and then click on this rectangle so that all 3 are selected. And once they're all selected, you click on this icon. It's called Group or Control G, and you'll see it combined together. Oh shoot. let me fix that really quick.
Quick question, for the triangles, did you make the dimensions like 14? So not like a complete point at the tip of the thing?
I might have. Actually, maybe the rectangle is.
Yeah.
Sorry for the technical difficulties.
Tinkercad is great because it's easy to visualize everything and you've got a lot of shapes available, but sometimes it is a little bit finicky about the edges.
Yeah, it's also browser-based, so like all your changes are saved and you don't have to worry about it after. How do you get the roof to rotate? Oh, okay, so this part right here. So you have these like 3 little arrows that you'll see on your object where you can rotate like this way. You can also rotate it like this way. And then you can rotate it the other way as well. Okay, let me just realign this really quick. I'm not really sure why this is not. Okay, I'm just gonna drag this.
Yeah, that's another solution that'll make it a little less finicky, is you can just increase the sizes of the triangle roofs, and that way when you make a hole, it'll won't leave that little border.
Okay.
Nice.
Okay, now hopefully when we combine this together. Okay. All right, does everyone have something that resembles this? All right.
We have a yes.
And now looking at this, oops, let me just put it over here. So you can see there's kind of like a little divot right here so that we can place like the UCLA logo and like just have a little bit more dimension to it. So if we want to basically create, another hole using our cube or our box and then placing it on top of our current object. So let's go back over here. Oops. All right. Okay. So this is, we just want this rectangle to basically be the size of the rectangle of our tag. And say we want kind of a border of like 2. Let's look at the dimensions of this first. So it's 30. And if we want a border of 2 over here and over here, we're going to want a height of 36. So because we have 2 and 2 over here. And so let's change this. So let's click on this and click on 30, oops, sorry, 26, my bad. And then you should have that. And then I'll show the align again, and then I'll show you how to remove the parts with the hole right now as well, Sophia. Okay, so now we have this, and let's see if we want a hole to basically be going inside this little area right here. We want the height of this box to go inside. So right now it's laying flat on the box right here, or our tag right here, because the height is 5. But if we go lower, you can see that it goes deeper and deeper into it. And so we want to just have like a depth of like 2. So we're gonna have it down to 3. Or sorry, 3 units above our work plane, but 2 inside this little area. And so now I'm going to show you how to group it again so you get rid of this area. Okay, so now you click on this on both objects. You can also just highlight everything that's in your workspace and click on group. And so now you should have this little divot right here. And then if you have that ready, just type in yes.
Wait, sorry, what did you just do there?
Oh, okay, let me just Control Z.
Sorry.
Okay, are you at this part?
Yeah, I am there.
Okay, so drag your cursor across these 2 objects. So left click and drag so that both are selected. And then you want to click on group. So you're combining the whole and the object, and the whole will basically cut that object where it was. And then,
can you go over lifting the box up again?
oh yes, of course. Okay, so right now, the box, so at a height of 5, this means that the box is 5 units above your work plane. But we don't want our box to just being laying flat on our object because it's not going to do anything. So we want it to go deeper downwards. So we click on this arrow, kind of like the normal pointing upwards, and then putting it downward, down 2 units so that we take out 2 layers of this like tag. What are the dimensions of the box hole? 54 by 26. And then now I highlight both of it and then I group them together. Does anyone else have questions on how to do this part? All right, I'm gonna just keep going. There's no questions. And now we want another kind of like triangular prism. So we drag this roof over here. We're going to rotate it so it's lying flat. So that should be 90 degrees. So 90 degrees. And then we also want to make it a hole. Then I will rotate it again once more, 90 degrees. Drag it over here. And so I will change the dimension to 26. And now I want to align this triangle with our tag. So that's kind of in the middle. And then now we want to pull this triangle out right here. And then if you got that so far, how deep should the hole be? So since the hole was 2 layers deep in here, we want this to also be 2 layers deep. So let's see. So let's just lift it. So that's 5 is laying on top and we want to go down 2 units. And then now we combine everything together. So now we want to make, we want to group it together. I think I put it down a little. Okay, I just need to look at this really quick. Okay. Okay, and now it should be like this. You can type in yes if you got that part so far. All right,
There we go.
that's awesome.
So in addition to the yeses, is anybody having any troubles up to this point?
I can't tell if people are too focused. Oh, okay,
We need a little more time.
take your time. And so like, I'm not gonna do anything else yet, but these are like other shapes that you can play around with. There's like a dice, diamond, torus. We're gonna use that later. And then we also have like text and numbers. So if you wanted to write your own text or just like pick a letter from here, feel free to do that as well. We also have like characters, just like some random shapes. But you're probably gonna work with like the basic shapes mostly. How big should the triangle hole be? Does that mean like the height on it or?
Oh, I mean like did we change the dimensions from the default dimensions at all? Like when you took the roof
Oh
and then
yes.
did you change it at all?
Yeah, it should be this right here. So you should have those dimensions for your triangle.
Okay, thank you.
I think Sophia and Cameron, did you guys get it? I'm just going to do it. Okay. Let's see. I guess in the meantime, our UCLA, we're gonna make this have a height of 2. So let's just click on your UCLA, click on one of the dimensions, click on the height, and then change it to 2. Oh, sorry, I meant 3. Okay. All right, great job, Cameron. Now we're going to lift it 3 units above, or sorry, 2 units. And then we're going to drag it into this area over here. Did everyone get that? And so like, it's a little bit big, so I'm just going to like make it a little bit smaller to 22. This way. So a 48 by 22. And just like a note, like these dimensions don't really mean too much, like the exact dimensions, because when you take this model and you put it into like your 3D printing slicer program, you can actually scale it to however much you want. And so now we're going to just align this UCLA logo with our tag. So you click on align. Oops, sorry, I clicked the wrong one. Align, and then this middle area. And now it should be in the center. And then now we're going to take this cylinder hole over here. And you can see that the sides are kind of like jagged, and you can change it so it's smoother or more rough. So if I put 8, I'm gonna have like an an 8 side, or sorry, this is 12 sides. I'll put 8. Actually, I think 12 is the smallest. Yeah, so if we have 12, we have 12, basically 12 edges. But if we want it more smoother to have like an actual hole, we can just drag it. And you can see it becomes a lot smoother. And so we'll just drag it in this area right here. Let's have like a radius of 5. You can just play around with it real quick. Oh, sorry, a radius of 2.5 and a diameter. And then, is anyone like still catching up to like before, or is it okay if I move on? Okay, I'm gonna assume that everyone is okay. Oh, just kidding. I can also work with you after too, Sophia, to help you get up to speed. Okay. So now we also want to align this hole. So right click. So click on this hole and then shift and then click on this tag right here. And then you want to click on align and then to the middle. And so it should be there now. Then you want to combine the hole and the tag together. So you click on here, click on the tag, and then you group. Now you should have a hole. And then once you have that part ready, feel free to type in yes in the chat. All right. How big is the tag hole? So the diameter should be 5. And then the dimension of the ECLA tag is 48 by 22. It can be whatever size you want as well, but this is kind of just like what I would prefer. All right, and now we're going to get a torus over here, drag it in here. Now, looking at what we had over here, we're going to basically place it halfway on top of this tag and then combine it together. Now I'm just gonna pan over here. All right. Let's see. We can make the dimensions a little bit bigger. Let's try 9. Okay. And then once we have that, we can also change kind of like the thickness of our torus. So I would say this is probably good. 1.82. And then we're going to click on our tag, shift, click on our torus, and then we want to align that as well. So right here. And then move this. Oh, okay, just move this one. Okay. Okay. So you should have a 7 by 7 torus and a tube of 1.82. And then once you're done with that, you can just combine your tag and your torus together and group that together. Then once you have that step done, we're almost finished with our tag, but we still have a couple things to do. So if you're up to this step, please type in yes. All right, perfect. And now just for like aesthetic reasons, you can change the color of your object to like blue. So you have like kind of like UCLA colors. And then you want to change this to yellow over here. And so I'll show you again. So you click on the object and you just click on the color over here. And then now you want to group them together. Just select everything, group, and they should all turn one color. But if you wanted to keep the two colors you had before, you click on the object, click on solid, and then click on multicolor. And that should display the two original colors you had. So once you're finished, finally, the final yes in the chat. All right. Oh yes, so there is a way to separate the two combined objects. So you just select everything again, and then you ungroup them. And so if I like click on this, and then I keep ungrouping it, like you'll see the torus is not connected anymore. Okay, and then, oh, thanks for coming, Tim. And then how do you make it multicolor? You click on your object and then you select multicolor. Right now, I don't think it's, let me combine them really quick. So after I group them, they turn to one color, but then if I click on it again, I can click on the color and then click on multicolor. Okay, nice job, Corwin. And now, if you guys, oh, sorry. And then at the end, you want to export it to an STL or OBJ file, but for now, you can just focus on doing an SD file. Where did it go? Oh, there it is. I'm just gonna name this UCLA tag in my downloads, and then I'll save it. And now it's right there. And then I'll go back to our slides. Okay. So this is like if you already have like, if you have a 3D printer and you want to use the slicer software, this is something that you would go through. If you wanted to like follow along, you can also download the Ideamaker slicer software. And the Makerspace uses the Raise 3D Pro 2 Plus printer, which this software is for. So essentially, when you first open up the application, you'll see like the printer settings. So this is the type of printer you want to select. Then you select the amount of extruders. So usually people like print in one color, and that would be like one extruder for that color. Sometimes people get fancy and they have like two extruders. And then this is like the filament size. So like we mentioned before, the two types of materials for 3D printing is like PLA or like ABS, which is like the most popular. This printer setting is set to use PLA 1.755 millimeters. And so once you have this program up, you want to import model to basically import your .stl file you just exported from Tinkercad. And then here are a few options that you will have to basically play around with your object. Basically to pan, view it in different orientations, just like we did with our Tinkercad. You can move your object around this space, which is the physical space that your object is going to be printed in. And then you can also rotate your object. This is one, scaling is probably the one that a lot of people use the most because you either want your object to become like bigger or smaller, depending on what you want. And then once you're ready, you click on Start Slicing, and then you'll see this setting pop up. So you want, so you have like 4 different options. So you have ultra high quality, standard, and speed. And ultra high quality is going to mean like you're going to have to wait like a longer time because it's going to be a little bit more precise versus speed. Usually people select speed just because they don't want to wait a long time. And then once you're done, so you've imported the .stl file into the slicer program, then you're going to export it into a G code so that your specific 3D printer can understand kind of like the amount of layers, the path it's going to print your 3D object. And then I'll do a quick tutorial after this on how it will look like. And then you can also see the actual layers of what is going to be printed in your preview. And I'll just go back to Ideamaker. So if you already have this like downloaded or anything, I'm just going to delete this first. So you want to import model. I just download this .stl file. Oh, I had 2 objects, so it imported both of them. I'll just delete one of them. Okay, never mind. I can only do one for now. So you can basically rotate it around like this way or that way. And then you can also scale it. So this is where it's like really important of like the physical dimensions that you want to print. So you click on your model and then you can have a uniform scaling. So if you either scale any direction, everything gets bigger. But if you wanted to scale in one direction, you just don't select that and then change it from there. And then you don't really need to do anything else usually. So if you do, you just want to start slicing and then you don't really need to set anything else up. You just need to select speed, the correct extruder type, and then your printer type, and then you click on slice. And so now you'll see the estimated print time. It's like 1 hour and 39 minutes. It gives you a little price estimate and how much material you'll be using. And then you should just click on preview so that you can see the layers of your actual tag. And so what these little like beds on the bottom are is so that when you print it, when you first print, it's going to be really like janky because it's like warming up the filament to melt onto the bed. So that's why they have this like little bed right here, and you can just like rip it off. It's really easy to take off your actual object. And so now you can see layer by layer as I drag it left and right, like how it looks like. And then with like a specific layer, you can just look at like how the printer is actually going to, like its path that it's going to follow. If I just like drag it left and right, you'll see like the tag is being made. And so I'll just close preview. Whoops, sorry. So then I'll just export it, and then wherever it is, I'll save it there. And then like Travis mentioned before, you usually have like a USB stick or like an SD card that will plug into your 3D printer. Okay, I'll show you with my own 3D printer really quick. Okay. So like, sorry, this is kind of jank, but here's the 3D printer right here. This is like the filament. Here's like the control panel. Here's your bed right here. And then coming out, you have like this micro SD card that has all of your files. Okay, I'll just leave it over there. But that's basically the process of 3D printing, and if you have like any files you want to print, like feel free to just send it to me and I'll print it for you if you're near the Westwood area. Let me go back to the slides. Okay. Okay, I'm just going to cancel this because I want it. All right, and so there is another website called Thingiverse where people already make these STL files, and you can like literally just import it into your Slicer program and just print it from there. People have really cool things, like they have like this baby Yoda right here, I guess like a COVID mask, a Black Panther. And then now it's time